Good morning and welcome to today's webinar. My name is Aranza Zugalan and I'm a member of the BuildUp editorial team.
Welcome to BuildUp, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, BuildUp is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. BuildUp brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The BuildUp portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? BuildUp disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the BuildUp community, or subscribe to our newsletter to receive the latest news. However you participate, the BuildUp portal is here to inspire, inform, and connect. BuildUp, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
It is a pleasure for BuildUp to host today's webinar and workshop event titled Smart Solutions to Accelerate the Digital Transformation of Buildings, brought to you by BuildON and SMARTeeSTORY projects and BuildUp. This online workshop is split into 4 main parts, during which smart buildings experts from BuildON and SMARTeeSTORY will share their vision of smart buildings. Before we begin, we invite and encourage the audience to send us their questions or comments to the speakers throughout the session. To do so, please use the GoToWebinar question function at any moment during the presentations. These questions or comments will be addressed during the Q&A session at the end of the presentations. Finally, we would like to inform you that you will be able to find the recording of this workshop on the BuildUp portal and our YouTube channel in the coming days, together with the presentation slides. And now, with no further hesitation, we will move directly to the welcome and introduction for today's event, presented by Sofia Mulero Palencia from Fundación Cartif. Sofia, the floor is yours.
Thank you very much. First of all, it's a pleasure for BuildON to be part of this webinar today. So thank you very much to the BuildUp organization for hosting this event and for the invitation. Thank you also to our colleagues from SMARTeeSTORY project to collaborate with us. We hope this is the first step of a long collaboration, and that we can be in contact in the near future to be how both projects progress in parallel. Having said that, maybe we can look into the agenda of today's meeting. I cannot see the agenda yet.
Yes, we have a little problem, so perhaps you can, there you go.
Okay, thank you very much. Okay, so we will start trying to understand very well the problem we are facing with both projects, which is the context and the framework around. I will go through the details of this presentation, and after that we will focus on both projects. We will start with an introduction of BuildON. We will focus on the key aspects of the project, our main key exploitable results, our smart transformer toolbox, and also the validation activities in the five pilots. After that, we will continue with the SMARTeeSTORY project. We will again go with an overview of the project, check the key expected results on the pilots, and finally we will have a joint session in which we try to focus on how the smart building solutions are close to users, how users will interact, and we will be engaged in our activities. We will have a final slot for questions, a 10-minute slot, in which you will be able to ask all the questions for the whole session. Having said that, I think we can start with the first of the presentations. So, okay, I will start with the problem statement and framework this first session of the webinar. As I said before, it's important to understand very well the context in which both projects were conceptualized. The goal was efficient, sustainable, and inclusive energy use. More in particular, we are talking about the topic of smarter buildings for better energy performance. It's an innovation action, and it's funded by CINEA. This goal is placed in Destination 4. This destination addresses activities that target energy demand side for a more efficient use in buildings and industry. In this case, we are focusing on buildings. And the idea is to focus on cost-effective ways to support the transition to climate neutrality. For these aims, toward this decentralized and climate-neutral energy system, this destination bets on the use of, on the one hand, digital technologies to optimize energy consumption, and this will open the door to new business and revenue opportunities thanks to this new way of flexible consumption. In terms of scope, sorry, I want to quickly. In terms of scope, the projects under this goal mainly focus on improvement of these cost-effective solutions to predict, assess, monitor, and control buildings in real time to optimize the energy performance. And to this end, they are expected to, on the one hand, enhance the interoperability of the existing systems, from technical building systems to even the building and the grid, but always considering to ensure the security and the privacy aspects. Secondly, its projects under this goal want to maximize the use of renewable energy sources, also to optimize energy efficiency, and to demonstrate that the potential of these solutions is huge and can provide huge energy savings. Moreover, these projects are expected to contribute to the enhancement of smart greeniness of buildings, and even more because it's also important to highlight how the way these smart solutions improve the smart readiness of buildings. So this is something that needs also to be assessed. Finally, users have a very important role. Users need to be included in the loop of this smart transformation for buildings, and to this same, it's important to provide user-friendly solutions, and also to help users to take decisions, to be supported by tools that can provide a good support for this aim. Finally, it was also expected to build flexibly services, considering other options that were not intended for energy management. One of the most relevant aspects of these projects is that it is expected to reach a high TRL by the end of the project. So it's one of the most relevant challenges of these projects. If we continue with the expected outcomes, first of all, we can talk about these more innovative, affordable, and user-friendly products and systems to help to monitor, improve the energy performance. Secondly, thanks to the optimization and the integration of different technologies, including the use of renewable energy sources, storage, and services, it is expected to increase the energy performance of building. We will be able also to provide more easier and more systematic use of smart products and services to achieve energy savings, even when energy renovation is not an option. This aspect in particular is quite interesting, how has been faced from both projects. We had a very different perspective, as we will see later on. Yeah, we will see how this will be tackled. And finally, it's expected to have a high replicability to increase the number of buildings that adopt these smart building solutions, devices, the digital infrastructure, in order to be able to reach this higher smart building space. And having said that, we can move to the next slide, in which we will be able to delve into the details of both projects that are presented today. And next one will be BuildON project. This presentation will be done by me, and also Nikos Dimitropoulos from National Technical University of Athens will provide further details on the technical aspects of the project, and also on the pilots, the demonstration. So I will continue with this presentation, giving an overview of BuildON. In terms of context, we will check first the key aspects of the project, which is our consortium and what each partner brings to it, which is our vision, the scope, the approach, and after that, the technical proposal and the pilots. So BuildON stands for affordable and digital solutions to build the next generation of smart European buildings. It was funded under this call, Smarter Buildings for Better Energy Performance, and it's a project which started in May 2023 and will last until October 2026. It was funded by CINEA with a contribution of almost 6 million euros, and it's coordinated by CART. In terms of consortium, we have 20 partners coming from 9 countries. We cover a lot of stakeholders in the whole building value chain, and also have the expertise from different kind of organizations, starting with large companies. We have service and technology providers such as EDF or RINA Consulting. We also have European SMEs having multidisciplinary expertise in the ICT world, areas of construction such as Facada, One Team, Holistic, and Yodibo. We also have a non-profit organization, ICONS, an association, Euroheat and Power. Both of them are supporting with the dissemination and communication activities, and also the demonstration campaign. And in the case of research and academy, we have quite a lot of institutions such as Cardiff, NTUA, URAC, BTT, La Rochelle, UCL. And finally, as I was saying before, we have a large number of stakeholders covering the whole building value chain, starting from facility managers such as Cordia, Anesco, Veolia, energy supplier, EDF, building owners, ECA, Veolia, the municipality of Gimnia, and a Second Life battery manufacturer, Biplanet, in Spain. If we continue now with our vision towards this European building transformation, we need to go back again to the context. So we are in a context in which the European Union is committed to this decarbonisation, trying to reduce the energy consumption, greenhouse emissions, and in this context, buildings play a very relevant role. The policies have evolved in this line, trying to enhance the use of the renovation in buildings and also the use of digital technologies. These digital technologies can provide a very can be seen as something with a huge potential for this thing, and projects under this call are committed, as I was saying before, to bet on the use of digital solutions in order to facilitate this transformation. Which is the vision behind BuildON? In BuildON, we want to bet, first of all, on the use of IoT, edge cloud, interoperability technologies in order to have a framework in which is possible to access to the heterogeneous data around the buildings, the heterogeneous energy systems that we can find. And it's also relevant to count on automation and advanced automation and control modes so that we can interact with these systems and integrate them with existing systems, and new systems can be integrated together. Moreover, it's very important to bet on the use of digital twins and artificial intelligence technologies in order to provide functionalities to predict, optimize the consumption in buildings. And we cannot forget the SRI indicator and all the framework around in order to be able to improve the smart readiness of buildings and to unlock all the potential behind these smart technologies. These together will enable to have smarter buildings, but also smarter users that will interact with our systems in an easy way. And why is this also relevant? We are in a context in which there are still a lot of non-technological barriers that we need to overcome, starting with the lack of awareness of the potential of these smart building technologies. Also, the SRI recommendations, there's not a clear pathway to contextualize them. That's why these recommendations are not still very adopted by everyone, and also the lack of business models and incentives behind these technologies, which is more important, the lack of these scalable and replicable solutions in order to improve the smartness levels of buildings. These solutions usually are vendor lock-in, and they are not replicable enough so that we can extrapolate them to new buildings. So what does BuildON propose? Okay, BuildON wants to provide this highly replicable generic solution to give this intelligent to provide these intelligent capabilities to buildings, facilitate the integration of these heterogeneous data, heterogeneous systems and technologies that we can find in buildings, and help to build this next generation of European buildings. So we are considering this approach in which we can see the building as a service. BuildON is built on the concept of smart building, the well-known concept we may know from the European Commission Annex 81, in which there are three main aspects that need to be considered. First, that the building needs to be managed itself in an efficient way. Secondly, that the building needs to interact with users. The third one, that it also needs to interact with the environment. So in line with this, BuildON will adopt the use of standards in order to maximize this interoperability and in order to face that the problems that we have with vendor locking solutions. This will be combined, secondly, with a set of predictive prescriptive analytics, providing functions for monitoring, assessment, and benchmarking, fault detection, prediction, and profiling. And finally, this will be also connected, and on top of this, we will have a set of automation and control capabilities in order to be able to manage the building in an efficient way. Finally, users will be benefited from all these solutions, from this next generation of functionalities based on data analytics and control technologies, and they will have a set of tools that will enable the interaction with buildings in an easy way. And now we will delve more into the details of the technical approach. I give the floor to Nikos. He will present this part and also the pilots.
Okay, thank you, Sofia. Let me check the control. Okay, it's working. All right. Hello, good morning. Thank you for joining this very interesting webinar. I'm Nikos Dimitropoulos from National Technical University of Athens, and I will present in a few slides our approach on the technical side and the connection to our pilots of the BuildON project. As Sofia mentioned earlier, we need to reach a high TRL level, and this is this figure you're seeing now. It's too much technical, but it's important to identify this and discuss a little bit about the solutions in order to understand how the solution we're going to develop and deploy can be that high of a technology readiness level. So the main idea of the BuildON project is to connect with buildings, make them more smart, let's say. So that is, we have in the BuildON project, we have a lot of typologies of buildings, we have a lot of energy carriers, we have a lot of different systems, different vendors, and our main approach is to identify all these and connect with them in order to provide our services. How do we do that? Is on the edge domain control layer, as you can see on the middle, a bit on the left. Needing the high TRL level, we have a viable and commercial solution on board of our project. That means we use two gateways in order to connect with residential and commercial buildings based on the needs of the project. That means that we need to facilitate data streaming on both ways. That means to take the data out of the building in order to provide and create services, and then back on the building in order to provide this output of the services. This on a technical level, it's very, let's say, difficult. We want to make it vendor agnostic. That means that we are dealing right now with different vendors, with different systems, and all of this need to be somehow streamlined in a unique solution in order to make it interoperable. As we go on this process, we have this vendor agnostic and in an abstract layer, let's say, of how the data are being streamed. We can use it in order to provide our services. As mentioned earlier by Sofia, we have lots of different services, lots of different, under the scope of different things. This is the energy management system, user empowerment tools, comply with the EU initiatives, and all this need to be translated in also a technical layer. So if I could sum up in a few sentences what we're going to do, all this technical work, is that we want to connect with the buildings, interact with the users in a meaningful way to both understand their needs and requirements, and to create the services, use the user input, both on the data side and their approach, how they would like to be benefit from the services. All these need to be on a high technology level in order to make this replicable. That is that the service we're creating, of course, they're being deployed on real life applications, but eventually we want to be able to replicate them in different settings as easy as possible. So right now, this is more of a vision. We are still in the first year of the project, so we're finalizing an architecture. We have very promising results. We have different vendors, different systems, different data streams that we are able to abstract in a unified way. So that means that when the services, the map of services on the right side, perhaps I could show it right here, the map of services, that means are the monitor, assess, predict, and optimize, can be easily replicated and not be vendor specific, or how the data are being processed, or what is the specific service that someone would like to create. So all in all, we create services that could be replicable in any type of building, although also that is the vision. Okay, so this can be encompassed in the Smart Transformer Toolbox. This is pretty much it, the previous slide on a more not visual way. On the technical clockwise, we want to create the ITH Cloud Interoperable Framework. That means the architecture, how we take the data and insert the data back to the building or control the building for building data exchange operation. Smart energy management system, there are analytics, the map analytics optimization services. That means we will provide services to monitor, to see the energy assets, to provide service flexibility services, control services, control the heating and cooling systems, encompass EVs, all of this battery storage. We'll see later on a little bit about the services. And finally, the digital twins for building performance simulation, a smart building operation. Continuing on that, also it's not so much, it is technical, but we identify the social aspect of it in order to have 5 user-friendly tools to empower users in order not to use the service in silo and be able for the building stakeholders that we have in our project and we have identified can be able to use the services and not only, let's say, technical people. Finally, and this is we later on the project, as I said, we are in the first year still, all this information will be translated into data-driven, innovative energy business models. How this high TRL level that we will achieve, I heard some noise, sorry, how this high TRL level that we will achieve can be also commercially viable for our partners. So to dig in a little bit on the services, we can say, as I said earlier, we have the map of services, monitor, assess, predict, and optimize. This pretty much describes everything that we will do. On top of that, we have the empowerment tools. So let's start with that. The empowerment tools is the user empowerment service we have identified, the SRI-based tools. That means we're creating a service that easily can calculate the SRI levels of a building, and after that, we have a decision support system in order to update the SRI level. And user application, that means we provide interfaces for each of the service and each of the stakeholder as abstract as possible based on our services in order for the building users to be able to identify, to see the results in an easy and user-friendly manner, and a digital building logbook. After that, these are the empowerment tools that we have envisioned. After that, we go to the strict, let's say, map of services where we use data. So of course, we're going to use artificial intelligence, machine learning, deep learning applications. So that means in order to be able to have a building energy asset monitoring benchmark, building energy fingerprinting, behavior of the consumers, of the residents, behavior of the system of its building, and this collaborate with the automation and control services. So this means user comfort optimization strategies. You may understand here that this easily like how the users like the thermal comfort. This translates to how the building operates within its apartment, its room, the whole building altogether based on the stakeholder. Asset control services, that means we have on our pilots, which we'll see a little bit later on, we have batteries, we have storage, we have EVs, we have the internal system, district heating network, how these assets can be controlled in order to provide some optimization strategies, be that user comfort, be that grid flexibility, we'll see. After that, we have the digital twins, and this completes the loop. We have the modeling, actuation, performance simulation. So we have 2 types of digital twins: the digital twins for building performance simulation and digital twin for smart building operation, which is for specific stakeholders, how they can simulate the performance and eventually all the services that we will create to be able to model before they are applied. So let's dive a little bit deeper on the pilots. All these will be deployed in 5 distinct pilots. The first one will be in Spain. The second one will be, I'm using the number here, will be in Finland. The third one in Poland, fourth on France, and the fifth in Greece. We have included in our proposal, in our project, different buildings. We have representative typologies in multiple climate condition location in Europe, different energy system and configuration within the buildings we are using, a wide range of building stakeholders, end users, facility managers, municipal governments are also involved. In order to all this information, all this solution we will deploy to be able, with this abstractness we're trying to create, to ensure high replicability. This is in line also with a high TRL level. I will go a little bit more on the 5 pilots just to have an idea. Did it work? It got stuck, sorry. Okay, yeah, I'll go a little bit more in the 5 different pilots just to paint the picture of who are we involving. So the first one, we are in Spain, in a residential building in Valladolid. This is a typology. The climate zone, you can see some Mediterranean climate with warm and dry summers. And what do we want to achieve? New energy efficiency measures to buildings in which renovation and further breaks are not easily implemented and are posing technical limitation. That is a common problem. We cannot upgrade easily enough. We cannot provide solutions that have not considered that the upgrades cannot happen. So it all makes sense that we try to be vendor agnostic. How we'll do that? We're going to enhance the building automation control network. We're going to provide AI-based control features. So we're going to control the building there in order to improve cross-domain control of energy assets and optimize flexibility. And of course, as I said before, the digital twins will close the loop of the services. So here the digital twin will be generated to support energy performance simulation and operation of the residential building. Moving on the Finnish pilot, again a residential building, different climate zone, of course. So the idea here, not what we want to achieve, is to enhance the building energy performance of multi-story apartment. So we're going to improve the operational capacity and reduce the use of the gas powered by the district heating network. This is how they fulfill the needs. So we have the district heating network in our Finnish pilot. We're gonna also provide indoor environmental condition improvements for all residents. This is another service. So this is how we do this. We combine the energy carrier, the energy sector, the gas we'll use here with the service we're going to create. How we're going to do that? We're going to enhance the energy management. Again, we're going to, with the MAPO service, provide AI-based control features. Again, we're going to control the building here to improve cross-domain control of energy asset, optimize flexibility with the grid, and visual comfort. That means visual comfort. We have a service based on the lighting system of the buildings. And the digital twin here, we're going to support the energy performance simulation. Since we're talking about a multi-story apartment, we need to have a holistic view of this residential building. The third one is a kindergarten in Gdynia in Poland. Again, a different climate zone, typical marine climate. And what we want to achieve is to reduce the consumption of fossil fuels in favor of greener energy from renewable sources. The consumption in this building, the kindergarten, uses heavily fossil fuels in the electricity mix, so we're going to favor renewable energy sources with our services. How we're going to do that is with the AI, again, based control features to improve cross-domain control of energy asset and internal environmental condition optimization. The idea here is that we're going to opt for the renewable energy sources with our services, and of course we're going to combine that with the well-being, let's say, of the users, of the building occupants, of the kindergarten students, along with the internal environmental condition optimization. Again, here the digital twin will support the simulation. This is what I mentioned earlier, the municipal government, how this the idea here was how can we do this in one kindergarten and extend that solution if when we're over with it, when we're done with the project, to extend it to other kindergartens with this idea to reduce the consumption of fossil fuels. The final 2 pilots are not residential buildings, they're more commercial, let's say. The first one, or the fourth one here, the French one, is an office building in I cannot pronounce that correctly, I guess. Moret-Loing-Trovan, okay, it's in France, typical oceanic climate. And what we want to achieve is to monitor and control the energy assets of the office building this time, which it may sound similar with the previous one, but since we're discussing about a commercial building, a different type of use of our houses, it's different the aspects and the needs and requirements that we need to consider for our services. Be that at the occupancy levels, when it's working, the energy assets and the energy consumption that's needed in order for the building to operate. It has different needs on how we try to achieve the services. How we're going to do that to operate this building? We're going to enhance, of course, the energy management. We're going to provide control feature AI-based again. The idea here is to improve cross-domain control of energy assets, to optimize grid flexibility again, and internal quality optimization, internal environmental quality optimization. The digital twins again here is going to support the energy performance simulation and operation. And the final one, it's commercial buildings in Athens and Thessaloniki here in Greece. The fifth pilot and the second commercial, let's say, we split it in 3+2. A different climate zone again in Greece. And what we want to achieve is to enhance the operation maintenance activities and integrate renewable energy sources while updating the subsystem infrastructure. That means we're going to involve photovoltaics, and this, of course, is going to have a difference in how the building operates and how the assets, the heating and cooling, let's say, assets operates. So of course, other than the service we provide, we need to update the subsystem infrastructure in order to accommodate the RES introduction here. To monitor, of course, this is by default, monitor this performance of energy assets and reduce emissions by default, since we are introducing renewable energy sources, the photovoltaics. Here we have how we try to achieve it. It's, of course, enhance the energy management of the commercial buildings, provision of analytic services, again AI-based. This is the basis of the MAPO services, to improve cross-domain control of energy assets, photovoltaics, and the grid-related energy that's coming from the mix, the electricity mix, to optimize flexibility in order to satisfy their needs based on their self-consumption of the photovoltaics and the user comfort, the workers, the people who are working on these buildings, in order to have to introduce in our services their comfort, thermal comfort, and how they are working within the building in respect to the renewable energy sources. And finally, again, the digital twins will support the energy performance simulation operation. So these are the five pilots of BuildON. I try to paint a picture, and we have a final slide, which is, of course, now only a figure. We're still on the first year of the project. We try to create the architecture. As you can see, we have a lot of services. That's why some words are similar. As we progress, things will be more clear, because we're going to provide even on the same service is going to be tailored to the different needs and requirements of its building, of its use case we are working on, of its stakeholder. So if I have counted well, we have 11 MAPO services, that is from S1 here until the end, and the digital twins, and 5 user empowerment tools. Here, I think it's clear if you see here the 5 pilots, and these are the services we will deploy to them. It's here you can see easily how we try to envision all these services, and how not difficult but challenging it is for all these services to be deployed in different contexts. And that's why we need a good technical approach at first, because we need to be able to abstract it in order to create it and then replicate somehow. A final example to make this easy, just here to have it, since I'm on this row, the energy profiling service is going to be deployed in its pilot. It's an horizontal, but it has to be different in respect of the use case, the typology of the building, the stakeholder, the needs, the requirements. That means we cannot provide one service and this is it. We need to make it somehow 5 different services within the big service, and then be able to replicate it and say that this can be easily extracted, since we have a high PRL level, and can be deployed to other typologies upon the end of the project easily. That will be all from my side in the BuildON presentation. Now I can give the floor to Heidi, I think.
Yes,
Thank you very
I
much.
think here. Thank you very much, Nikos and Sofia, for this insightful presentation of BuildON. We go now to session 2, where the SMARTeeSTOry project will be introduced, and we will be proposed the key expected results and pilots. First, we will have Heidi Percuoco. She's from RINA Consulting in Italy, and afterwards Matteo Porta, also from RINA. Thank you very much, Heidi. The floor is yours.
Thank you. Okay, so welcome to our SMARTeeSTOry project presentation. First of all, I want to thank you, Sofia, for inviting us to participate in this webinar. I think it's a great occasion to see both the projects and compare them to see the main differences. Sorry, move too fast. Okay, so I'm Heidi Percuoco, serving as a coordinator for the SMARTeeSTOry project, working in RINA and collaborating closely with my colleague Matteo Porta, who fulfills the role of project scientific coordinator. So here there is our project agenda. I will do a brief introduction, show you some info and details about our project, as also our consortium structure and the role of the different partners involved. Then I'll show you some objectives and scopes for our project and how the key expected results of the project are connected to the outcomes. While then my colleague Matteo Porta will introduce you our project methodology, as also he will show you our 3 pilots located in 3 different European climate zones in the Netherlands, Spain, and Latvia. So here there are some info and details. So SMARTeeSTOry, what it stands for integrated, interoperable, smart and user-centered building, automation and control system for better energy performance of non-residential historic buildings, coupling physics and data-based approaches. As was already mentioned, it was funded, the call for that funded this project is under the topic D40103, so smarter buildings for better energy performance. It's an innovation action, and for the project we will reach a TRL 8. RINA is the project coordinator for this project, so our headquarters are located in Genoa in Italy. The total costs for this project are around 6.1 million euro, while the maximum grant amount is around 5.1 million euro. It's a confounded project because we will have 70% of funding for profit legal entities, while 100% for non-profit legal entity. The project will last for a year, so it started the 1st of May 2023 and it will end the 30th of April 2027. Here there is our consortium. So SMARTeeSTOry consortium is represented by 13 partners across 6 countries, including industry, partners, academia, research centers, small, medium enterprises, bringing expertise on historic buildings, smart buildings, and ICT. From Italy, we have RINA, Pellini, Schneider Electric, and Terra, while the partners from Spain are Tecnalia, Cuerva, Cartif, and the Andalusia Agency of Energy. From the Netherlands, we have the Technical University of Delft, from Latvia, Riga Technical University and Riga Energy Agency, from Greece, Exus, and from Germany, Steinbeiß. For this project, RINA will be the project coordinator. So these slides display the skills and the role of the partners involved in the proposal, in the project. So RINA, other than be the project coordinator, will take care to define the KPI panel to evaluate the impact of the project, to define the control strategies, and also to develop the digital software architecture of the SMARTeeSTORY system. Then we have the Technical University of Delft that will define the interaction strategies between a user and a smart automated system, while Technalia have the scientific knowledge in the field of building physics and will bring expertise in physics-based modeling for technical building systems. For the project, we have 3 technology providers, Schneider Electric and Terra. Will be the main technology provider, bringing in expertise related to the equipment interoperability, while Prelebrini is the technology provider for smart shadings. Then we have Exus, that will take care of data science, will cover the role and bring expertise related to data science expertise and ICT competencies that then will be applied to smart buildings domain for accurate forecastings of buildings performance. Then we will have Cartif as leader for the demonstration activities. We will have 3 demonstrators located in 3 different European climate zones. We try to divide the main partner that will work in different, responsible for the different demonstrator. So for the Spanish demonstrator in Granada, we have Cuerva and the Andalusa Agency de la Energía. Then we have for the demonstrator in Latvia in Riga, the Riga Energy Agency and the Riga Technical University, while for the demonstrator in the Netherlands, the main responsible is the Technical University of Delft. And then we have standbys from Germany that will guarantee a proper dissemination and communication plan, as also training and stakeholders engagement. Which is the objective and the scope of our project? The objective is to create a smart integrated building automation and control system to do what? To monitor and optimize the energy performance of historic non-residential building according to an innovative multi-domain approach, integrating the 9 domains proposed by the SRI methodology that are shown below: heating, cooling, domestic hot water, and so on. But keeping into account both the requirements related to the fact that we are dealing with historic buildings, as well as human requirements, and will include also real-time and active user engagement. SMARTeeSTORY system, what will do? Will automatically detect the building's user, and then will inform the optimization and control service on the specific preferences. The software and hardware solution that will be developed will be interoperable and cyber-secured by design, and will include the 3 functionalities that are required for a building to become smart. So it will have to adapt to the external environment, to change condition related to the demands of the building's occupants, and to optimize the operation of technical building systems. The project results will be validated in the 3 real-life demonstrator buildings. We will reach a TRL 8 for this project. The 3 demonstrators, as previously stated, are located in Latvia, Spain, and the Netherlands. Here we have a slide showing how the outcomes, the 4 outcomes for this call, are connected to our key exploitable results. The first and the third outcome are linked to the creation of the SMARTeeSTORY cloud platform. This platform will include some advanced energy services for monitoring, digital twin, analysis and prediction, optimization and control, as well also an interoperable technology kit for the digitalization of historical building. while the second outcome is connected to the development of physics and data-based model for the building performance analysis, prediction, optimization, and control, including also users dimension. While the fourth outcome is linked to the development of policy recommendation, tool for techno-economic assessment of digitalization in historic buildings, and some technical specification to implement satisfactory interaction between the user and the smart control. So I've completed the presentation. I leave the floor to my colleague Matteo Porta to show you our methodology and our 3 demonstrator. The floor is yours, Matteo.
Thank you, Heidi. Thank you so much. It's a pleasure for me also to be here in representation of RINA Consulting and also for the World Consortium of SMARTeeSTORY project. I should have the control. And I would like also to thank Sophia from BuildON coordination, and also the BuildUp team for having given us this possibility for presenting the SMARTeeSTORY project, and also the connection that we should have with the BuildON project, as Heidi said before. So I'm going to present briefly the methodology of the SMARTeeSTORY. SMARTeeSTORY project is divided into 3 main phases, and the first one that is related to the first part of the project is mapping the requirements. So with SMARTeeSTORY, but usually in this type of project, when some sort of design, a new design of technical building system is taken into account, for sure we need to have the knowledge of the requirements of, in this case, historic and non-residential buildings, because we made the choice to focus on historical buildings, since once one of the main requests from the call was to focus on buildings where the renovation was not an option, and the historical buildings, of course, represent the typical buildings where it's not so possible to intervene in basically on the envelope and also inside the buildings, because they are, of course, protected from an architectural point of view from their historical value that they have. And so this means that it's quite important to understand which are the characteristics of the buildings, and also the needs of and the requirements of the users that are using them. We are not talking about residential buildings, but we are talking about tertiary buildings, as we will see in the following. And so the first phase of the project is to map the requirements, even because it is quite important to understand which type of users are using the buildings, and which type of comfort they are used to, and understand also the difference between users and among them, because what we are going to develop it's a sort of control and management system that takes into account the user perspective and the user point of view. And so in this phase, we are going actually through the technical requirement of each of the 3 demonstrators, and then we are setting up a framework of KPIs that will be used then for the evaluation of the intervention that we are going to develop and to deploy. The second phase of of these, the methodology is related to the development of model and algorithms. And this phase is quite crucial. We are actually during this phase after almost 1 year from the project beginning. And here we are going to develop physical models and data-driven models based on machine learning techniques in order to for different purposes, basically. What the system is going to provide is an overall platform that will provide several services. One of them will be the possibility to control the different technical building system using basically model predictive control and optimized controls. And this needs several models to be performed. And for this, we are developing a technique using both physics-based and data-driven models. We need to forecast the performance and the behavior of the buildings, but also of the end users. And so this is quite important also because an entire work package of the project is dedicated to the end user profiling. And our colleague Alessandra from TU Delft will show you later how we are approaching this part. And yes, this will be, of course, connected with the phase 1, because, of course, once we will collect, we are collecting actually all the information coming from the buildings and the end users, we will be able to then design a software and hardware solution to address the control and the management of this type of buildings. The phase 3 is then the demonstration of our solution and the assessment of the impact. And to do so, we are going to perform a lot of activities. First of all, the data acquisition. Data acquisition is quite important in this type of application, and we are understanding how the lack of data and the lack of digitalized data it can be a barrier to the development of this type of solution. For sure, in the different countries of different European member states, there are different starting point for the digitalization of the buildings, and so it's quite important to have this clear when starting when try to develop this type of solution. So to have a clear representation of what is digitalized and what is not. And this because when you are developing as-built digital models or in general any kind of general digital models, data are quite important. And for sure, in this we are addressing this problem in SMARTeeSTORY, and this will be important also for the services that we are going to provide, and I will show you in the next slide. The last but not least is represented by all the activity of dissemination and communication related to this project, and as well as the exploitation strategy and the replication activities that are quite important in order to understand how this solution could be replicable. This is in a nutshell our SMARTeeSTORY system. Is represented by an IoT cloud platform that will include all the services that will will be provided to the 3 demonstrator in the case of the SMARTeeSTORY project, but that will be represent the generic approach of our methodology. So on the right hand side of this picture, you can see the 4 main services that we are going to provide through that platform, that are monitoring, analysis and prediction, optimization and control, and digital twin services. So this platform will encompass all these 4 services that will be deployed differently according to the specificity of each demo site. Monitoring, for sure, we will collect the data after the intervention, after the application of our digitalization measures, thanks to the forecasting models of the building developed within the SMARTeeSTORY project. We could provide some important information to the end users and to the facility manager regarding the analysis of the performance of the buildings, as well as the predictions of the performance in short and medium term. And then, of course, thanks to the development of the optimization and control algorithms, we will show to the end user how a digitalized system will work, and also more important, in accordance with the specific characteristics of the end users and the user archetypes that we are going to define. And then embedded into the IoT cloud platform, digital twin services will be also provided to the end users. That means that we will take advantage of the building information modeling, the BIM methodology and services. We will develop, and actually we are doing it during the project. We will develop a 3D representation of the buildings that will provide to the end user some insights regarding not only about the architectural features of the building, but also of the performance of the system. And this will be done with the development of an user-friendly graphical user interface that we are going to develop, and that will be specifically developed for different end users that will use the platform. And this will be done through a list of sensors and actuators that we are going to install at the field level. And then this will address the different building technical building system and domains, because for sure we are developing a solution in order to increase the smart readiness indicator of each of the building, as I will show you before. And this then will be done thanks to some components like edge computers and edge servers provided by our technology providers, that will act as an interface between the field layer and then the platform itself that will be cloud-based. Then, as my colleague Heidi shown before, we are demonstrating our approach in 3 different real-scale demonstration buildings: the Riga City Hall at Riga in the city center, the Faculty of Architecture of the Technical University of Delft, TU Delft, in the Netherlands, and the High Court of Justice in Granada, in Spain. Regarding the university, the TU Delft, the Technical University in Delft, as you can see here, we are proposing several interventions in the different domains. The different domains corresponds to the smart readiness indicator domains, where the smart readiness indicators is calculated to the application provided by European Commission. So we are approaching the heating, ventilation, the lighting, the dynamic building envelope, the electricity and monitoring control domains. As you can see on the bottom side and the right bottom side of this picture, we have calculated both baseline scenario and future scenario according to the method B of the SRI assessment. And okay, this analysis showed us that from a starting point of 21% of the baseline scenario corresponding to the class F of the SRI assessment, we are moving to the 78% of the class C through a list of intervention that we are going to perform at BuildOn. Regarding the heating domains, we are going to, for example, install a thermostatic valve for heat emission control. The thermostatic valve will be wireless connected to our system, and so we are going to define the setup temperature for their operative condition according to the specific requirements of the users that are working on the buildings, on the rooms, and for sure this will provide a sort of flexibility and also the possibility to interact with the external grid, because this of course will be part of the orchestration system that will use model predictive controls to set the optimal configuration of the heating system according also to the specific condition of the other system. For example, the ventilation domain. Ventilation system, here we are going to control the flow rate of and the temperature of the air that is provided, is supplied to the different rooms, with some the possibility to control the injection of the air, and this will be done according also to the needs again of the end users and to some indoor air quality sensors that we are installing at the room level. And this will be done also for the lighting system, because we are going to detect the level of light within the different rooms and to control it, balancing the external lights, so trying to enhance as much as possible the contribution of the external lights with the internal artificial lighting. And the dynamic building envelope will be addressed to the control of the solar shadings and the possibility to control also window opening and closing, and as well as the electricity domain will be addressed thanks to specific smart devices that will meter the electricity consumption of the different devices connected to the sockets of the rooms. All this will be orchestrated to our monitoring and control system. Specific optimization algorithm will be developed that will take into account all those instances, and in order to find the best solution that is from one side economically viable, and also taking into account the comfort conditions of the end users. The same will be done for the High Court of Justice in Granada. Here you can see applying the same methodologies, we are going to move from the 12% of class G of the baseline scenario to the 72% representing the class C of the future scenario, addressing these 5 domains: heating, cooling, lighting, electricity, and monitoring and control. As for the data demo case, the physical intervention that we are going to have in the High Court of Justice in Granada are going to address both heating and cooling system that at the moment are provided by an heat pump, a centralized heat pump that could provide both heat and cool via some air handling units. And the idea again is to develop a sort of optimization algorithms that can take into account the different perspective of the users and needs of the users that are working there. This will provide again a sort of flexibility to the systems that is quite important for the final SRI calculation, and also lighting and electricity will be included in this analysis and this control algorithms in order to again have the end user quality of working enhanced. Then the last pilot site of the SMARTeeSTORY project is represented by the Riga City Hall in the Riga City Center. Here you can see that all the 9 domains of the SRI calculation, including the SRI calculation, will be included. Here the idea is to pass from the 12% of the class G to 29% of the class B. We will work on the heating domain with the possibility to control the radiators via thermostatic valves, but also the possibility to control the ventilation system that provide not only fresh air but also heated and cooled air. And so the cooling and heating system will be connected to the ventilation system to provide heat and cool to the users, to the workers in the building. And we will have some metering of the domestic hot water consumption, as well as for the lighting system. We will have sensors to detect the light, the level of lighting within the different rooms of the buildings in order to control them properly. And we are going also to install some building integrated photovoltaics connected to electric vehicle charging station in the basement of the building and with the battery, in order then to coordinate also the electricity consumption from the different technical building equipment and the production, the internal production, also providing a connection with the dynamic prices of electricity prices of the Latvian grids that provide a possibility to have more flexibility for the usage of the buildings and to test our control logics to try to reduce the operational costs, but at the same time keep the comfort of the users enough high. That's it from my side. Probably I missed a lot of things regarding the SMARTeeSTORY project, but we are here to also answer to your questions that may arise. Thank you so much.
Thank you very much, Matteo. Thank you very much also, Avi, for the presentation of SMARTeeSTORY. We are running a bit late, but no problem. We have now a very interesting session about smart buildings, user interaction and engagement. It will be presented by Chiara Fonio from ICOMS. She's working in the BuildON project, and Alessandra Luna from TU Delft, working in the SMARTeeSTORY. This session is structured by formulating and answering questions related to the user interaction and engagement. First, Alessandra will do an introduction of the project. Afterwards, we will go to this very interesting way of formulating the questions. And at the end, Chiara will make a recap and a close about this session. So let's go for it. Alessandra, the floor is yours.
Good morning, everyone. Thank you very much. So we close this presentation by speaking about the users. As you've heard several times in the presentation today, both projects are looking at the users as central points and destinations for the outcome of the results of the projects. So the first thing we will do with Chiara is to describe who are the users that we are addressing in our project. So who are our target users and why it's important to include them? So starting from SMARTeeSTORY, in this project, we are looking at 3 different types of users. On one hand, the building owners, on the other hand, the facility manager, and finally, the end user. So in our words, the users, the people that are occupying, living in the building. Why are we doing so? Because on one hand, the smart readiness indicator as one of the objectives, together with energy efficiency and energy flexibility, also to improve some other aspects that are all related to the user. So the comfort, the health and well-being, the convenience, and also the satisfaction of the user with the information within the smart buildings. Of course, the core reason why we are doing a smarter building is to, on one hand, save resources, which include energy, but could be also water. But on the other hand, also to enhance user well-being and health. These two purposes are strictly interconnected, and there is no benefit if we only save energy without also improving the health. This is the big challenge that the projects are targeting. I'll leave the floor now to Chiara to describe who are the users in BuildON and why they're engaging them.
Yes, thank you very much, Alessandra. For BuildON, mainly the users are the end users of the building in the pilots that were presented before. However, the story, the BuildON story, is a bit broader than that, because this does not mean that the co-creation activities that I will mention later will involve only the end users of the building, because also in our case, the facility managers and the building owners are also involved. But the idea of giving the priority to the end users of the building is that we want to ensure, and here we go to the reason behind the engagement, we want to ensure that there is a user-driven design of the smart buildings. So what is really important within the frame of BuildON is that we apply, we use and implement very technologically advanced, as we saw before, technical solutions, but that we do not forget the humans in the loop. This is a key element of the BuildON user engagement approach. Shall we move to the other questions?
Let's go to the second question. I think Alexandra has the control.
I'm clicking.
Yeah. So yeah, how are users engaged in both projects?
So as also Chiara was mentioning, it's key to have the users in the loop. I'm trying to move the slide. It will happen at some point. As you can see, user interaction is very important. So it's very important the way users are engaged for several reasons. One of the reasons why current smart technologies are not widely adopted is also because of user dissatisfaction and not engagement with the solutions. In fact, I think if we think about our daily experience with so-called smart systems, they are often very disruptive to our daily activities, either because they don't meet our demands and needs, or either because the automated strategy is not really optimizing and enhancing our comfort and well-being. So for this reason, the manner, the method that we can apply to engage with the user is key, both to understand what are their perspective, what are their needs, what are their requirements, and this can be very diverse because users as people are very different. We come from different expectations, cultural backgrounds, awareness and knowledge of technology. So all of this has a key role. So in SMARTeeSTORY, we have a mixed method approach. So on one hand, we are engaging with all these different people with workshops and interviews, but also with questionnaires, so gathering data. And this provides the first part, the benchmark for understanding the diversity of expectation and requirements and needs, but also to have the opportunity to engage with people and have participatory approaches where also the final end users, the people that will use the building, can design the building and the automated strategy they need. The second part of the SMARTeeSTORY strategy, it will be based on artificial intelligence method and consists on the following. A number of persona or archetypes will be created, and the system will leveraging on a large database that we are creating on user expectation and requirements, will be able to predict and guess what type of people, user is in the building and what are their needs. This is very similar to the approaches that we are commonly seeing in our daily life in other applications like social media or web page. So in this sense, the approach of SMARTeeSTORY twofold. On one hand, there is an active participation and engagement with the people that are co-designing, participating, and providing feedback. On the other, their feedback to limit also the nuisance of having to provide feedback continuously for many years is incorporated in a smart user-centered AI strategy. I leave now the floor to Chiara to describe the strategy of BuildON.
Yes, thank you, Alessandra. The strategy of BuildON is similar, but only to some extent to SMARTeeSTORY, meaning that the users in the BuildON case are informed, consulted, or directly involved or mobilized, as you can see in the slide, and involved in the co-designing of some of the solutions that were presented before. And in order to do this, what we have done so far, because it's also important to understand where we are in terms of the time frame of the project. For the moment, we have represented the requirements of the users through user stories, and then based on this, we have come up with the engagement roadmap. So how to involve them, who to involve in the co-creation activities, and also the methods to engage them. So basically what we used was a very well-known engagement letter that goes from inform to empower, and within the different steps, the users will be involved either only, quote unquote, because this is already an important activity, either only informed about the solutions that can enhance the comfort of the apartment in which they live or in which they work, because in BuildON, as it was mentioned before, there are both private and public buildings. Or they will be consulted to understand whether the solutions, some of the solutions, meet their needs and expectations. Or they will be directly involved. What does it mean directly involved? It means that we are planning, this has not been done yet, but we are planning to organize, to carry out different kind of activities, from workshops to co-design sessions, for instance, to co-develop the interface of a solution. So in this case, you can see, while before I was saying that the story behind the user engagement is a bit broader than just the end users of the building, because different kind of stakeholders will be involved in these activities. On the one hand, for instance, the residents of a building, and on the other, but in the same room and around the same table, developers will be working together with the users in order to understand whether an interface of a solution goes towards the direction that they expect, or to collect requirements, or to provide feedback, or co-designing the solution. So the activities, of course, depend on the different pilot, the aims of the pilots, and what we have decided in the roadmap for engagement. Thank you.
Awesome, Chiara. And the third and one very important question is, what is the impact of the users' engagement? Alexandra.
Thank you. So once our objectives are applied and the methodologies, as we just shown, and being also applied to reach our objective, the impact we are expecting to have is the following. I think we might acknowledge that all of us are very different. Some of us might want to be in a building where, as soon as you enter in a room, the building is able to predict what do you need, if you need the lights on, if you need more heating, more ventilation. For other people, it's always very important to maintain control and feel empowered within the building. So in this sense, the impact of the solution we are creating is to be able to remember all these requirements that might be very different across people, and being able to predict and apply them depending on who is in the room and what is the task that this person is performing. The real novelty is also to do this without being too disruptive. So also without having to provide asking an unnecessary question to the user. So ultimately, the final impact is an indoor environment that is much healthier, of a higher quality, personalized and tailored to our needs, and an indoor environment that is achieving this by also saving energy, because it's also engaging with our needs and behaviors. Because let's remember that every time we also enter in a building, we are acting and operating the building, and this has an energy impact. So the possibility of really truly understanding needs give us the opportunity to both enhance health and well-being, but also save energy in the least disruptive manner. And this is really key at core of the Smart Readiness Indicator. That's why, as I said before, the Smart Readiness Indicator, it's also assessing comfort, health and well-being, so all the parts related to indoor environmental quality, but also the way this is achieved by scoring convenience and information, which are part of the interaction strategy. So to conclude, the impact will be a space that is personalized, energy efficient, with minimum effort from the user perspective. And I leave now the floor to Chiara to explain the BuildON part.
Yeah, thank you. I will be very short because I think that many things have been said already. And I also captured only one aspect of the impact here, the overall impact of the end user approach in the frame of BuildON, which is to come up ultimately with solutions that are services, solutions meaning services and tools which are co-designed. So the idea, as I said before, is to really keep the users in the loop from the very beginning, so that solutions are not imposed on them without collecting requirements, without involving them in a wide set of activities, but is to co-design some of the solutions, so that at the end of the day, there will also be an aspect related to the trust and the ownership. It's very important that in a project like BuildON, but also in other projects, I think the technical development goes hand in hand with the human requirements, human needs and expectations. So if the impact is the co-design solutions, I think that we will reach the goal that we have in mind. And now I think that we can move to the conclusion. Okay. So the conclusions that we have for both projects, I think that a lot has been said so far from different perspectives, but also as we have understood that there are some similarities between the two. So the conclusions are that definitely we both use a bottom-up approach to user engagement without, as I was saying before, imposing solutions to the users, but rather involving them at different stages and with different methods, tools, and for different means. Another aspect that was emphasized and highlighted both by Alessandra and myself is that at the end of the day, what we want to provide are more tailored solutions for users. For instance, to have a better comfort in the building that they are visiting, I should say, because it really depends on the purpose of the buildings that we are that we are considering. And another thing that emerged from both presentations is that a variety of tools will be used, and also methods to have the users really on board. So the last sentence that we would like to share with you, and the last statement, is that in both cases, digital transformation of buildings is really carried out throughout an overall inclusive approach, following perhaps slightly different pathways, but the overall goal is basically the same for both projects. And I will stop here. Thank you.
Thank you very much, Chiara. This is a good phrase to finish, in fact. So you see, we are running out of time, but I don't want to jump without, I mean, I have many questions, and we have many questions that I can provide you. And for our audience, you can, both projects are also already in the platform of BuildUp, so you can find them and find the links to the presenters today. But after hearing all of you and the similarities in between the two projects, you are absolutely mixing keywords that we have now in Europe. You have digitalization, you have users, you have renovation. You are kind of all around. But you have just begun in May 2023, right? So you have rough 8 months working in your projects. What are the, I will make a transversal question for all of you, just answer from your perspective. What is the challenges that you are finding, because you are mixing non-residential historic buildings with many constraints? You are mixing users of very different types. You have very different approaches to building typologies and countries. What are the main challenges that you have found to date in the implementation of your different projects of BuildON and SMARTeeSTORY? We can go first, for example, to Sophia. She was the first and organizer who gathered everybody.
Yes. Hi. Thank you for your question. So actually, as we can see, we are considering different contexts, but the problems that we need to face are quite similar. In the case of BuildON, we are focused on residential, also tertiary buildings. Actually, the challenges, I mean, when we were writing this proposal that later became a project, we found that the stakeholders behind are quite different, so we cannot approach to them in a similar way. The needs they have are different, so that's why in the case of BuildON we are proposing different solutions, but we have quite a lot of elements that are in common. As has been mentioned before, we need to face some challenges such as the adoption of these kind of solutions. Users don't trust on them because this has not been proved enough, let's say, or at least someone in its home is not still totally convinced to adopt something like this, because the potential of the solution has not been fully demonstrated and fully explored. So we have the opportunity here to reach this kind of user. Actually, this represents a great part of the building stock. So this will be one of the most challenging aspects of our work, to be able to convince them that what we are proposing is affordable, can provide more benefits that they thought, and also that the interaction with these solutions doesn't need to be difficult. We are trying to provide some solutions to empower them and also to support this kind of decisions. So that will be one of the most challenging aspects we need to cover. On the other hand, we need to think also about the context and all the systems that the buildings we are considering have. In the case of the tertiary buildings, we are not dealing with the same kind of technical and energy systems. So the solutions that we need to provide there are different, and we need to face all these problems about the vendor lock-in solutions, and try to provide something that can be replicated and generic enough so that can be adopted without having a great knowledge of what needs to be installed. I guess that this can be also extended to their historical buildings that are being considered in the context of SMARTeeSTORY. Even there might be other challenges then, because they need to consider that many actions cannot be done because the building needs to preserve its essence and so on. So to sum up, that will be the most critical points I can see so far. I don't know if any of you want to add something to this.
Yes, I will add what I mentioned before. So the importance of having enough data, because when we are talking of digital solutions, when we are talking a lot of digital twins, we are talking a lot of models. Of course, we need to create models. If we're also talking with building information modeling, that means that we need information about the models and the buildings to create the buildings, to create models. And so this means that we need the data, and this means that we need to digitalize our information, for example, coming from the cadastre or coming from already digitalized tools using, for example, DVG, AutoCAD, for example. But if we don't have data, this could not be put in place. I mean, and the point of the data is quite crucial, because it's also inherent to sensible data that are coming from the end users. So the point of data, I think that is quite crucial when we talk about digitalization in general.
Completely agree. In fact, I have several questions about data, but as I hope that you will continue to come with, on BuildUp to present your outcomes during the length of the project, I hope we have more time to next generations to talk about how are you doing. So let's finish here. A big thank you to the speakers for an incredible and very insightful presentation of the projects. And to the audience, for sure, for attending today's webinar. A reminder that you will be able to find the recording of today's sessions on the BuildUp portal and our YouTube channel in the coming days, together with the presentation slides. Also remember that all these projects are linked in BuildUp, so there are featured and have their websites, etc. So please go there and have more, if you have more interest in them. BuildUp has also several webinar sessions already in the pipeline for the rest of February and for March. So keep an eye on the BuildUp calendar of events and our social media for updates on this. Be also sure to check on the BuildUp website and follow us on social media for updates. We wish you a very pleasant end of the week. Thank you and goodbye. Thank you very much, you all. Bye-bye.